Hi! In this video, you'll learn about whole numbers. You will learn how to find the prime factors of whole numbers. You'll learn how to find the square root of whole numbers using prime factorization. You'll learn how to find the highest common factor of whole numbers, as well as find the lowest common multiples of whole numbers. Okay, so what is a factor? A factor is a number that can divide another number without no remainder. Can you think of numbers like that? Yes. 1 is a universal factor because 1 can divide any number without no remainder. Take a look at this number 21. Can you think of a number that can divide 21 without no remainder? Of course, 3. 21 divided by 3 is 7. Also, 21 divided by 7 is 3. Hence, the factors of 21 are 7 and 3. Now let's take a look at prime factors. Since you already know what factors are, so what are prime numbers? Prime numbers are numbers that have only two factors, 1 and itself. Can you think of some numbers that are prime? Yes, 2. 2 has only two factors, 1 and itself, which is 2. Another number is 3. 3 only have two factors, 1 and 3. Now 5 is another prime number. It has just two factors, 1 and 5. Another number would be 7. 7 also have two factors, 1 and itself, which is 1 and 7. Now, you would observe a trend between the second prime number, the third prime number, and the fourth prime number. You see that there is a difference of 2 going on. To get 5, we added 2 to 3. To get 7, we added 2 to 5. So, let's just keep on adding 2 and see if the numbers we get will be prime numbers. 7 plus 2 is 9. But is 9 a prime number? Of course not. 9 is not a prime number. The reason is because 3 can divide 9 without no remainder. So 3 makes it a third factor. 1 and 9 are two factors, and then you have 3 as another factor, which means that 9 is not a prime number. Let's add 2 to 9 and see if that would be a prime number. 2 plus 9 is 11. Is 11 a prime number? Of course, yes. No other number can divide 11 except 1 and 11. Now, if we add 2 to 11, we would have 13. 13 is also a prime number because only 1 and 13 can divide 13 without no remainder. So you see, you can get prime numbers by just adding 2 and checking if there's any other number that can divide those numbers without no remainder. Now, if we add 2 to 13, we would have 15. 15 is not a prime number because 5 and 3 can divide 15 without no remainder. If we add 2 to 15, we have 17. 17 is a prime number because only 1 and 17 can divide 17 without no remainder. I want you on your own to write more prime numbers and check if they are correct. Alright, we cannot define what prime factors are. Remember that factors are numbers that can divide another number without no remainder. And we said that prime numbers are numbers that have only two factors, 1 and itself. Hence, prime factors are prime numbers that can divide another number without no remainder. Now, if you're asked to find the prime factors of 33, what you want to do is begin from the first prime number, which is 2, and check if 2 can divide 33 without no remainder. Can 2 divide 33 without no remainder? Of course, no. Next, we go to the next prime number, which is 3. Can 3 divide 33 without no remainder? Of course, yes. 3 divide 33 will be 11. 3 is a prime factor of 33, and also 11 is a prime factor of 33. There are no other prime factors. The prime factors of 33 are 3 and 11. Alright, here is another example. What are the prime factors of 45? Let's begin with the lowest prime number, which is 2. Can 2 divide 45 without no remainder? Of course not. 2 into 45 is 22 remainder 1. Hence, 2 is not a prime factor. Let's go to the next prime number, that is 3. Can 3 divide 45 without no remainder? Of course, yes. 3 can divide 45. 3 into 45 will give us 15. So, 15 is also a prime factor of 45. Now, what other number can you think of that can divide 45 without no remainder? Of course, 5. 5 can divide 45 without no remainder. 5 into 45 is 9. Hence, 9 is also a prime factor of 45. So, the prime factors of 45 are 3, 5, 15, and 9. Now, let's look at square roots by prime factorization. If you're asked to find square root of large numbers, it's usually difficult to use perfect square to find those numbers. So the easiest way to find the square root of large numbers is by prime factorization. Let's take a look at an example. Find the square root of 196. It's simple. To find the square root of 196 using prime factorization method, you just use prime numbers to divide through 196. This is how. You have 196. The first prime number is 2. So you check, can 2 divide 196 without no remainder? Of course it can. Here is a trick to knowing numbers that 2 can divide. If the last number is even, that is, the last number can be divided by 2, then that entire number can be divided by 2. We have 196. The last number in 196 is 6. So can 6 be divided by 2? Yes, it can. 6 divided by 2 is 3 without no remainder. So which means that 2 can divide 196 without no remainder. I hope you got that. Now 2 into 196 will give us 98. Can 2 also go into 98? Of course, yes. So 2 into 98 is 49. Now, can 2 go into 49? No, it can no longer go into 49. Let's check the next prime number. The next prime number is 3. Can 3 go into 49 without no remainder? Of course not. Let's check 5. 5 is the next prime number. Can 5 go into 49 without no remainder? Of course not. Now the next prime number is 7. Can 7 go into 49 without no remainder? Of course, yes. 7 into 49 is 7. 7 can still go into 7. 7 into 7 is 1. Now we can express 196 as the product of the prime numbers. So 196 is equal to 2 times 2 times 2 times 7 times 7. Now let's put this in indices, or let's pick it in pairs. Now you see that 2 appeared twice, so we can pick it as a pair. Also, 7 appeared twice. That means it's a pair. When you have numbers appearing twice like that, all you have to do is pick one of it. So 196 can be expressed as 2 square times 7 square. If you have this, then you can just pick one of the numbers. Hence, the square root of 196 will be equal to 2, we picked 1 of 2, times 7, we picked 1 of 7. 2 times 7 is equal to 14. Hence, the square root of 196 is equal to 14. Very simple. Now, let's take a look at lowest common multiple, which we can also call L.C.M. So what is lowest common multiple? Lowest common multiple is the first multiple any 2 or more numbers have in common. Least or lowest is the same thing. Least common multiple or lowest common multiple is the first multiple any 2 or more numbers have in common. Let's see how to find lowest common multiples of some numbers. Find the LCM of 10 and 15. Here is how. Let's tabulate this. So we have 10 and we have 15. Begin by checking if 2 can divide any of these numbers without no remainder. So, can 2 divide any of these numbers? Can 2 divide 10 or 15 without no remainder? Yes, 2 can divide 10 without no remainder. 2 into 10 is 5. Since 2 cannot divide 15 without no remainder, we'll bring it down. Yes, can 2 divide 5 or 15 without no remainder? Of course not. Now we move to 3. Can 3 divide 5 or 15 without no remainder? 3 can divide 15 without no remainder. So 3 into 5, it cannot divide it without no remainder, so we'll bring 5 down. 3 into 15 is 5. Next, check if 3 can still divide 5 without no remainder. 3 cannot divide 5 without no remainder. We move to 4. Can 4 divide 5 without no remainder? Of course not. Next, 5 can divide 5 without no remainder. 5 into 5 is 1, and 5 into 5 is 1. Hence, we can say that the LCM of 10 and 5 is the product of the multiples. So, the LCM is equal to 2 times 3 times 5. 2 times 3 is 6, and 6 times 5 is 30. Hence, the answer is 30. Now, let's move on to learn something very important, and that is highest common factor. We can also call it H.C.F for short. What is highest common factor? Just like we said, lowest common multiple, highest common factor is the highest numbers that can divide 2 or more numbers without no remainder. Now, let's take a look at this example. Find the highest common factor of 9 and 12. In order to find the highest common factor of numbers, take the LCM of the individual numbers. That wouldn't be difficult, isn't it? So let's first find the LCM of 9. Now we have 9. We begin with 2. Can 2 divide 9 without no remainder? Of course no. We go to the next number, and that's 3. Can 3 divide 9 without no remainder? Of course yes. 3 into 9 is 3. 3 can also go into 3 without no remainder. 3 into 3 is 1. Next, we'll find the LCM of 12. Can 2 go into 12 without no remainder? Of course, yes. 2 into 12 is 6. Can 2 still go into 6 without no remainder? Of course, yes. 2 into 6 is 3. 2 can no longer go into 3 without no remainder, so we go to the next number, which is 3. 3 can go into 3 without no remainder. 3 into 3 is 1. Now, check the factors of 9 on this side, and we also check the factors of 12 on this side, and see which numbers are common between these factors. The first number on this side is 3, so we check on this other side, is there 3? Yes, of course there is 3, so we write down 3. The next number is 3 here. We check this way, is there another 3 here? Of course no. If there was another number 3 here, we'll multiply it by that number. If there's another number common, we'll also multiply it by that number. And then the multiplication of these numbers will be the H.C.F. Since we do not have any other number in common, then the H.C.F of 9 and 12 is 3. We have come to the end of this video. Bye.